first question.
Yeah.
And why did they think of this technique? And what question were they answering at that time?
Yeah. Uh, yeah, I can answer this a little bit broadly. The first thing is that I wouldn't spend too much time thinking or worrying about DNA hybridization technique because this is quite obsolete now. But overall, the idea is that if you have two strands of DNA, which are kind of the more closer they are, the likelihood of it hybridizing. And then they look at a certain temperature. Yeah, so these have kind of worked. Uh, I'm not sure you need to kind of look very specifically for the Trogon study, except that this was the starting point, how they started looking uh, at genetic differences. It doesn't even include genetic sequences. So this is a very broad kind of way of looking at genetic similarities at a time when sequencing was very popular. So I wouldn't worry too much about this. The second question.
Why did you think of this technique at that time?
Yeah, so
Question.
that I answered that. Yeah, I mean, thought about this only because it was not possible to work with sequences for a large number of species. It took much before that kind of data could be had, and and yes, those have been there. There are now genome-based studies as well. Previously, it was not whole genome, parts of strands of DNA. Uh, yeah, I think there's Reddy et al. I think it's Hackett et al. Paper, which used multi-gene sequencing. That was the first paper that came up with that. It really changed a lot of our understanding of genetic relationship of species. Now we are talking about whole genomes, which is much broader data sets. I think we lost Amrita, but very quickly, there I found the list of questions. What is a primer? Uh, so primer, like like a template, So uh, you know that a specific gene starts at a specific, point to point. So the primer is the sequence that is used there. Just a moment.
Uh,
Yeah, sorry. Yeah, I had just something else here. Yeah. So so basically, if you have a specific, you're trying to get a specific region of the genome. So many chromosomes, like thousands of base pairs. Now you're trying to get one specific section of sequence. Okay, so to get that, you need to find a piece that fits the a piece that fits just before that and just after that. Okay, so it's basically like using if you have a big Word document and you use a string, right? And you know that this set of this particular set will get you a specific page in a whole book, right? So you say that search for this, and then you will get to a specific page. And that's exactly what a primer does. Primer is a unique combination that will just work exactly, at a specific. Now, if your primer is not very good, it can amplify multiple paths in different parts of the genome. So that's not a good primer. So if that means you've not designed well. A good primer is something that sticks only there and nowhere else. Yeah. And this people have done using various trial and error and so on. Earlier, getting primer sequences was a big deal. And people were used to be very secretive about what primers that they have used, because the search string, was people confidential. But slowly that changed, and then it became for replicability of science, it became important that all the primer sequences are shared. So that's what that is. And what does a nucleotide? So nucleotide is just basically it's just string that one of those alphabets that is a nucleotide. Yeah, so basically, primer and nucleotide. Watch that video a little bit closer. Essentially, what you need to kind of what you're trying to do is that you're trying to get at this particular sequence. Now, I already explained how there's a search string kind of thing. It goes and attaches here, and there's the other one that attaches there. Now, you have to basically, we're going to synthesize this. So to synthesize that, you need to have those nucleotides available. So, the polymerase kind of adds these free nucleotides to this chain. Yeah, so I can't possibly do justice just by explaining like this. But so you need to watch. I think there's a link to a video, and if it is not there, I can send it again. This video, I think there's a Sanger Institute video, which is really good on Sanger sequencing. Yeah.
So I can later share that to the discussion forum. You
Yeah,
can send.
yeah. Sure. Yeah. Yeah, I'm trying to find this thing as well. Yeah. Any other let me see. Oh, where's the
So I think Ram joined. Yeah, these all are Ram's questions. He's yeah, asked
Yeah.
about PCR output for the method.
What is the PCR output? Do we need PCR output for this method? Yeah. So PCR, what PCR does is that it makes these millions of copies. Essentially, you're trying to get a small fragment. It's a small bit, but you want that information. So because it is not found, the detection, your ability to detect that is not very good. Do is that you multiply this millions of times, and that is what that's what that's what the PCR is. It's like taking a small strand of DNA and then making a swimming pool of the same strand, so much so that through this sequencer, you have, because multiplied this so many times, you will get a much clearer readout. Yeah, I can see, Ranjita, you have a question, but let's just finish the other set that's there. Uh, uh, PCR is a starting step where one attempts getting copies of the DNA, while Sanger and steps towards sequencing the PCR output. Well, the PCR only works with the sequencing. Otherwise, there is limited. Well, no, you're not. Yeah, you're right. Yeah. So at the time when there was no sequencing, you could amplify, but the point was that it became more relevant after the sequencing became came into full. Really, pretty much everything does get sequenced. There are some situations where you have to sequence. For example, even in birds, a common is sexing of birds, where I think I have it in a slide somewhere. Depending on so if you want to, if there is a monomorphic birds where males and females look alike, based on the number of copies of, it's like how you have X and XX, birds have ZW. So, if you're targeting something which is on just one of the chromosomes, then you would get a different length. Okay, so people who are really clever about this, and they said, oh yeah, if there are two copies, then it should get like it should amplify at two different lengths. So when you visualize the output of the PCR, then you would get different bands. Yeah. I don't know if this is all very clear, but let me try and give another example. Okay. So suppose you have uh, you get a DNA, like there's a fecal sample, and you identify which cat species this is. Actually, this is a study that there's a paper on this. So it can be a leopard, it can be a tiger, or it can be like a jungle cat or something like that. You have three different cats, but you don't know which is what it is. So you don't want to bother to sequence. You just want to do a species ID. So essentially, what you do is you create a set of primers which different lengths of a gene. So you could, let's say one amplifies 700 base pair, another amplifies at 500, and yet another at 200. So when you visualize this on an electrophoresis, essentially one species, let's say the leopard or tiger, is 700, another one is 500, and third one is 250. Yeah. So so then without sequencing, what species it is. Okay. So this is a very like relevant case where people have used PCRs without sequencing, but now everybody uses sequencing. Yeah. So what's the next question?
It's the
Yeah,
haplotype.
haplotype. Yeah, yeah. So uh, haplotype is nothing but a unique string of sequences. So what you're trying to say is that you are trying to book with another book. Okay. So this is like, I don't know, two organisms or two species. But of course, you can't read every word of all the pages in the book and compare it with every word in all the pages of the other book, right? Do is just get some sections, and then you're going to compare just those sections and say, are these the same? Yeah, how similar they are. Now, haplotypes work is that any set of data that you get, any string, let's say if you're in, especially in the Sanger sequencing world, let's say you get a 8 base pair length sequence. Now, if this 800 length, 800 length is like ATGC 800 times. If this is identical to this in this book and the other book, same haplotype. Suppose it is different by even one alpha, right? That's a different haplotype. So that's what a haplotype is. I hope that's clear. Yeah. Now, DNA extraction. Just a moment. All right. Yeah. Now I can see much better. Yeah. Uh, DNA extraction and mitochondrial. Yeah. Basically, when you extract DNA, it has everything in it. Okay. So if you are what you're trying to say is that a bird, and then we take one drop of blood from the bird, which is what we actually do. We extract DNA. And when we are extracting DNA, the protocol that is followed, it will extract everything, all the DNA, whether it is, in fact, our group also works on avian malaria, which is parasites. In that one drop of blood that we get. Okay, so you have RBCs, and RBCs are nucleated, and that has infected by, let's say, Plasmodium. So when you extract DNA, the mitochondrial DNA of the bird and the nuclear DNA of the bird, but like, the parasite DNA also. So it pretty much amplifies everything that is there in that one drop of blood. Okay. It in everything, but all DNA comes in. So the ability to separate our mitochondrial and nuclear and all of that can only come with specific primers, or you call them. Yeah, yeah, that's a bit. Mm, I can imagine that this is a little intense. Yeah, I mean, essentially, learning is what I think people learn in a entire course or something like that. I try to crunch it into a 1 hour lecture. So yeah, if you don't get everything. Uh, so yeah, all
I
right.
think the next question is kind of a feedback to overall course,
All right. Yeah.
PG Raj, but
Yeah.
he also have asked about this, what you have almost covered, the primers and basically the same thing. He was saying he was not able to follow these terms. Yeah. And
Sorry, which one?
this is from Vijiraj.
Uh-huh.
So
What
he
what
was,
what is he not able to follow? The primers is
yeah. What we discussed, almost we
okay.
covered.
Okay,
Yeah.
okay, okay. Okay. Yeah, yeah. Yeah. See, I mean, there's what is that? BSc, there's like, yeah, it's like it's a full course, I think. So don't feel too bad if it's not very clear. It's gonna take some and yeah. There was another. Is it from the last one that's included there, Amrita, which is
Yes. So
about the
this is,
timing?
yes. How we
I,
can say the 5 million years ago exactly based on what determines this the aging. I mean, yeah,
yeah.
the
So
separation.
this is again something really clever that people have done. Um, there are it's a whole field of study, but I'll try and simplify it. A simple way to look at it is that if how mutations accumulate, and we are just, let's say, just talking about random change. Uh, so that means that over time, there's these mutations kind of accumulate over time. So if you are able to figure out how much change happens in a set period of time, able to extrapolate that. And I'm speaking very broadly. There are more complex ways to do this. The simple assumption in what I just told you is that there is a molecular clock. Yeah. So previously, people thought that, like mitochondrial DNA, for example, cytochrome B, like that, have like a 2% per million year kind of a clock. Especially with birds, people thought this very strongly. So in fact, if you read Trevor Price's book, I think he talks about which need to have a 2 million year divergence. So so the clock, the way um, the genetic change accumulates over a specific time, that is how that is kind of in a simplistic way. In more modern computed analysis, actually you'll have a phylogeny, and then you can kind of date parts of the tree. Phylogeny is just a relationship of different in a tree, but you can say, oh, I don't, I a fossil of a bird that looks like this owl. So maybe it was like this ancestor, and that happened with some radiocarbon dating. This was found at this time. So there's a specific time that you can fix with that as well. So people are now clever. People are kind of figuring out ways to kind of put in dates from other methods onto these trees so that you can then calibrate the whole tree. So essentially, you only got let's say 2 or 3 fossils, but you can then just use that information to date like a tree with, let's say, 50 species or something like that. Yeah, these are very, very analytically advanced fields. A lot of there are a lot of models that go into it, and who do research on this just basically focus on these models of evolution to fit that. Sorry, that was a very long answer, but yeah. Uh, uh, yeah, I see that comment, Ram, and please don't be disheartened by this. Like I said, I tried to kind of provide a brief kind of glimpse of various things. All of this should be a full course by itself, but of course, don't have that. So if you decide to dig deeper, there is a lot of depth to go into. Uh, yeah. And what are the latest techniques to be used in avian studies besides conventional one? Yeah, let's if you think about this, remember the of comparing two books. Um, so the question is, are these two books different? Okay, those are the kinds of fun things we want to know. And the books here being two different individuals or two different species. Uh, what is like the minimum that you can do is, I don't think you can use this analogy for the uh, DNA hybridization, but science is where you take a set of uh, and you see if a string on page 30, first paragraph, first line matches uh, the page 30, first paragraph, first line in the second book, right? You say, oh, maybe just comparing one page, one paragraph is not enough. Let me compare one more page. So you go to flip over to page 50, and then you take one line from there and you compare that as well. And then someone says, well, that's still pages in a 500-page book. You can keep doing this until you get to like every single page in the book. And then you say that, oh, yeah, it is the same book. Right? Or you say, oh, well, it is 10% different or something like that. But maybe you don't need all the pages in the book. Maybe you can take a smaller like set of uh, pages, and that might be enough. So the general people have had in using mitochondrial DNA is that um, only one way that it kind of gets inherited, and it's passed on maternally. Uh, so the nuclear gene can tell a different story. So this differences could lie, but um, you don't need, people have tried to do this once the whole genome sequencing came. People have tried to go of genes and so on. And most often they say, well, you don't really need that much data. It depends on what you're trying to resolve. Sometimes there are some ancient divergences which are, there's just not information. So then you need to kind of add a lot of data before it gets resolved. Yeah. So whole genome sequencing is pretty much the latest kind of technique that is there. But people actually use the entire genome. They use parts of it. How much they use really depends on the questions and how much variability is there to start with. All right. Any other questions?
Yeah, I think we covered all the questions. If any of you have any questions, please type in the chat box or unmute. And if there are,
Robin,
yeah, please.
Robin, I have a quick one. So, you mentioned that, this is a full-length course that one can learn. So is there from your knowledge, is there an NPTEL class that you can take where one can study over 12 weeks, the details, dive deep into this, at least the basics of molecular biology?
Yeah. So no, but there's a book that I can recommend.
Please.
Yeah, I'll send it on the chat. This thing, or maybe it's better if Amrita posts it to everybody.
Oh, that'll be great. That'll be
Yeah.
great. Thank you so much.
Sure.
Appreciate it.
But it's not easy. It's not easy to find something like that in general. There are some good books. Yeah, otherwise I don't know where yeah, it's really not too many options you have.
Yeah, that's a comment in the chat box. I think we covered all the questions. So this is the last week of basic course in ornithology. So exams are coming May 3rd, and all the best for everyone. So if you have any questions, please post in the discussion forum at least a week before, so that I can get to the replies to you as soon. Yeah, thank you everyone for joining. And I think, yeah, Robin, you can leave the session. Maybe Manjari said she will join because she want to discuss a question from the discussion forum, which she couldn't in the for one of her lecture.
Sure.
Yeah, maybe
Yeah.
students can. Rest of us can wait. Yeah, thank
Yeah,
you.
sure,
Thank you.
sure. I'm happy to have engaged with all of the course. So yeah, look
Yeah,
forward to meeting
thank
some.
you so much. Thank you, Robin. So yeah, we will wait 5 minutes, and if she is not joining, then I'll let you know. Otherwise, please wait. So yeah, Manjari said she'll join in 5 minutes. So we'll wait.
Amrita ma'am, can you just ask your team of excellent professors for any book that I've asked in the chat or list? You can ask for that kind of a book if possible, because I'm into bird watching, anything like that. You can mail us, it will be useful. Thank you so much.
Sorry, you asked regarding, I didn't get you clearly.
Ma'am, on
So
the chat
the
list, I have actually asked for a book name or a type of books or a resource where I can find types of birds, more to do with bird watching, guidance on that. I put it on the chat today, ma'am. Can you just ask your
sure.
professors and
Yeah,
just mail us, please? Thank you.
yeah,
Amrita,
sure.
maybe I can help you.
Ah,
Amrita, can I
sure.
help?
Yeah,
Please,
sure.
please.
Thanks.
Yeah, please.
Okay, sure. I'm based in the US, but I've done a lot of birding in India. So there are several books that one can go if you are into bird watching across the country of India. Uh, Definitely, Vikram Grelwal's book is fantastic. You know, if you just go Google and Google Amazon India and just type Indian birds, you will see there are specialized books on birds of Himalayas or generalized books across the whole country. Grimmett's book is fantastic. So there are several books, and as I think Dr. Rajpal points out, different books follow different conventions. So if you want to be in touch with some of the more recent conventions like Clement's book, you want to be careful about which book you choose, because if you want to get into details, but you cannot go wrong by choosing any one of those books. That if you go to Amazon India and type Indian birds, you would find several books that are recommended. Of course, unless you are very specialized into Himalayas or wherever, or Rajasthan for that matter. But pretty much any book will be very helpful. And the reason why these are helpful is it helps you to locate the birds, and of course, depending on the climate, you also know what kind of morph it is, and helps you to identify birds, and also know it gives you a lot more details about where you can find them, what you expect from these birds, and the range maps, and so on. So you cannot go wrong by just choosing just about any book. I have about 4 different books for India, and pretty much all of them are very, very useful. So I hope this sort of answers your question.
Thank you so much, sir. I'll follow your advice. Any specific book that you found exceptional?
Okay, yeah, for that, the answer is Birds of a Pictorial Field Guide to Birds of, I'm sorry, Pictorial Field Guide to Birds of India, Pakistan, Nepal, Bhutan, Sri Lanka, and Bangladesh by Bikram Grewal, Grewal. He's a very prolific author. He writes in the newspapers too. He's been there for many, many years, writing on birds. So you cannot go wrong with that book to start with.
Excellent. Thank you so much.
But let us say that you want to go into birds of Kerala, that you want to be very specific, very regional. Then Dr. Salim Ali's book on birds of Kerala is phenomenal as well. So you cannot go wrong with any of these books.
Today's lecture I heard it today, so it's not today's lecture. The citizen science lecture was excellent. I hope all of you heard it. It was excellent. Gave a lot of resources, actually, a lot of information on that lecture.
Just another quick comment on that comment. That lecture, as you can guess, is at least a couple of years old. So since then, there has been a lot more advances in the world of citizen science, but directionally, that lecture was just fantastic.
Yeah.
As I agree with you.
Yeah, that's what I meant. Directionally, and the resources is what I'm saying. A lot of resources he shared, which was very, very useful for my kind of person.
जाना तो लीजिए, आज भी नहीं हुआ जाना। अरे मेरे को मालूम ही नहीं हो रहा, पैसे हार्ड हुए हैं। Hi Amrita, I have logged in.
Yeah, hi Manjari. So I'll read out the question. So this is the week 4, question number 12, where few of students have emailed me. So I'll read out the question. So read the statements given below and choose two options that represents a correct condition under which an altruistic act will be favored by natural selection and will spread in the population over evolutionary time. And the options are: option A, the cost to the actor outweighs the benefit to the recipient. Option B, the cost to the recipient outweighs the benefit to the actor. And option C, the recipient and the actor are close genetic relatives. And option D, the recipients of an altruistic act will reciprocate the same for the actor. So I think students have confusions with this option A and C. So the correct option we have marked is option A and C, but they are asking option C and D also were the correct answer. I think you are muted.
C and D should be the correct, no, not A and C. So if the recipient pays back, so some sort of reciprocal altruism, then also it will spread
Yeah,
in the population.
yeah. Sorry.
And if they are close genetic relatives, then also it will spread in the population. These are the two correct answers. That's what I had marked, no?
Yeah. Sorry, I said it wrong. So the C and D is correct, but students are asking, could that A also be correct? Yeah.
Repeat A again. Cost to the
So the
actor,
cost to the actor outweighs the benefit to the recipient.
but then that cannot evolve, no? If the cost is greater than the benefit, the cost to the actor, and you have to see the benefit to the recipient, which itself has to be weighed down by the basically the relatedness, right? So RB minus C should be greater than 0, right? Which means RB should be greater than C. So if the cost is greater than the benefit, how can that evolve? It doesn't fulfill Hamilton's rule, no? So therefore it cannot. Then cost to the recipient itself is wrong because recipient as such is the receiver of the altruistic act. So the receiver is only benefiting. The receiver is not paying a cost. So therefore B is also wrong. But both C and D are correct if you are close genetic relative or if you are going to pay back. So reciprocal altruism. Does that make sense?
Yeah. I hope that is clear to the question, but students have asked regarding this reciprocal altruism. Can it explain more on not only to this particular question, but they were, this recipient actor, they got confused with this terms
No,
and
recipient and actors are very clearly defined. The one who is showing altruism is the actor. You are doing an act which has a cost to you, but has a benefit to somebody else. So you are the actor. The recipient of the beneficiary is the recipient. So that is very straightforward. The cost cannot exceed benefit because then the system cannot evolve. RB minus C should be greater than 0, no? Okay. Then
Yeah.
if there are any further questions, then I can write it down and give it to you.
Sure. Sure.
Anything
Yeah.
else about this particular cost and benefit and recipient and actor?
No.
This topic?
No, only this question the students have raised. I think Ram, you had the similar question, right? Which we discussed right now. I hope this is clear now. And one more person has asked. I think he is not here, joined. Yeah. Ram, could you please unmute? And is this clear to you?
Oh, yeah, exactly. Thank you, Manjari, for answering that question. But I thought I had one more where there was the selection of the use of the Hamilton rule, which I thought, at least I didn't get the correct answer. I was just looking to see where it is.
Find and
Oh,
tell
yeah.
me.
It is the question is 14. I want to just know, Dr. Manjari, as to how we got to the answer. That's the most important thing for me. It's not about whether I got the right answer or not,
Yeah,
but the
absolutely.
idea is, how did you get the right answer?
What's
Question
the
number
question?
14.
I
The question
wouldn't
is,
know. Yeah.
in a monogamous bird, an individual performs an altruistic act, thus that saves the life of 4 siblings at a cost of 2 offsprings to the altruist. Would such an altruist act evolve according to Hamilton's rule? And there are 4 options. And of course, I got the answer wrong, but I just want to know the answer. The correct answer is because 2 genetic units are gained and 1 genetic unit is lost. What I really want to know is what was the value of R that was used in this calculation?
So that's the paradox because and that's why it's a tough question. So it's not surprising if you didn't get. So don't be too harsh on yourself. The thing is that a sibling, in case of a diploid organism, and an offspring, both will have the exact same R, 0.5. And it is monogamous, which basically means that there is no chance of extra pair copulation, no extra pair paternity is there. That was the point of saying it is monogamous. Now, if there are 4 siblings would give you a fitness value of 4 into 0.5, 2 genetic units, correct?
Correct. Got it.
And 2 offsprings will give you the 2 into 0.5, 1 genetic unit.
Oh, got it. Oh, okay. That was simple.
Yeah.
See, I knew there was something to it that I just simply didn't get.
That's
I
okay.
tried that with so
Because-
many different types of combinations that I couldn't get the answer. So
Yeah, it's simply because you need to know R will be equal to 0.5 for both cases.
that's where my problem was. Okay, thank you.
Okay. Amrita, anything else?
No. We have covered the questions which was remaining, and I think if there is any questions a week before, if it is, then I'll get the replies from professors, any of the chapters. Thank you, Manjari, for joining in. Thank you.
Bye. Bye.
I also want to thank Dr. Manjari's lectures. It's been fascinating and
Thank
learning
you.
all these things. I've spent hours and hours learning more.
Wonderful.
So exciting indeed.
Wonderful. I would love to hear from you. So yeah, please do write to us.
Will do. Absolutely.
Okay.
Yeah, one more question before, I think in the comment, this is regarding the vocal mimicry of common myna. So
I think that Robin I did
yes,
not.
Robin had, yeah. But what I heard from Robin and Samira, who took this topic, was like common myna is not a vocal mimic in the wild, as what they have suggested to me to this particular question. Yeah, I
Amrita,
hope.
actually, I posted research papers from Nature on that topic where somebody had done well over 18 years of research, both in India and in other places outside of India. And that answer is pretty much settled. So my whole problem with that question was it was marked wrong. So that's why I raised the question to begin with. So I did my own research. And since then, it's been corrected. So, but in the very opening, Dr. Manjari points out that it is a mimic only in captivity. So that was very, very clear to me. So
Great.
Super. Okay. Amrita, is there
Sure.
anything else? Did I miss
No,
something?
no, no.
Okay.
Yeah.
All
Thank
right,
you. Thank you
guys.
so much.
Bye-bye. Thank you.
Thank you. I hope, Viji, that answers your question. Yeah. Yeah, all the best for your exam preparations, exams. I hope it's going well. So please write to me in the discussion forum if any of you have any questions. And please don't worry and don't take too much tension about those exams. Just go, brief through this lectures once again if you want, and then just take it easy. Yeah, the questions are all answerable only. And wish you all the best. And thank you all for joining.
hey, thanks for your service, Amrita. Appreciate it. Thanks, because it's a tough thing trying to coordinate with a lot of different people, trying to get all these professors to answer. So I know it's a difficult job, and I've done one of these about 45 years ago. So it's but those days there was no internet. But it's TA job is not an easy one. So thank you for your service.
Thank you so much, Ram. Thank you. So bye everyone. See you.